Alright, welcome to the second video of 2.1 types of materials. In this video, we'll be looking at the start of the second box here. So melting points can be used to classify materials into molecular and non-molecular lattices. Electrical conductivity of non-molecular materials provide evidence for three types of primary bonding: metallic, ionic, and covalent. And also, more for the third video that we'll do, classify materials as molecular, metallic, ionic, and covalent network, which is lattice, given relevant conductivity and melting point data. In this video, I would like to get on to more of the background information about the melting points and so on. So slide that I'm looking at is going to be this one, slide number 10. Okay. So physical state and also the physical change. That's actually defined by what sort of bonding that happens between the particles inside of any compound or any substance that you have. For example, one on your left, which is this side, yep, this side. One on the left, you see substance which is at the gaseous state, liquid in the middle, and solid on this side or your right. What's shown there is that the distance of each particle at each state, as well as what sort of interaction is happening in between. For example, on your this side, so solid state, particles are close to each other, either that's a molecule or whatever. They're close to each other because the interaction is very strong. For you to melt it to liquid state, which is in the middle, you would have to provide a lot of energy. So could be heat, could be I don't know, electricity, could be light, I don't know. But without those energy that would overcome the interaction between particles, they won't change its state. Liquid, the particles are sort of interacting with each other, but they're free to move around. And in gaseous state on your far left, they are not really associating with each other because there's not much interaction between molecules. So intermolecular force, I'll say that again, is fairly low. Okay. Now, on the next slide, slide 11, particles arrangement is different in atoms. Physical change, again, is caused by different amount of energy that's added or taken away. So, on your left again, you see solid, liquid, and then gas. Now, the changes are, well, hope you're familiar with these terms. Solid to liquid is called melting, and liquid to gas, that would be boiling or evaporation. Boiling happens inside of the liquid. Evaporation happens at the surface of the liquid. That's the only difference. And on the other way around is condensation and then freezing. I think I will show you a demo of sublimation, which is a change from solid to gas straight away without going through the liquid state. And if you can do sublimation, by cooling down, you can do the deposition, so opposite of sublimation, that is. The deposition in chemistry means a change from gas to solid. It's not raining, it's not the snowing, like what you would hear in meteorology. Now, I've been mentioning about the energy. Now, you might recall endothermic and exothermic reaction. You can also use the same terminology, endothermic and exothermic, in terms of these physical changes as well. For example, for solid to become liquid, you would be adding energy. So energy is going into the particles, and that will continue to make liquid to gas. Because energy is being absorbed by the reaction, it's considered to be endothermic reaction. There is outside energy that's going into it. The opposite of that, so gas losing heat to something else to be cooler, so it becomes liquid. So energy is coming out of it. And that can continue. If you're looking at change from liquid to solid, energy goes out. Because energy is going out to the environment, the surroundings, it's considered to be exothermic, exiting, energy exiting. There's a note there. Energy only moves from higher place to lower place. If you're looking at, say, ice cube, and if you're touching it, you feel cold. It's because your finger is losing energy to ice cube, so that ice can gain, solid water can gain energy to become liquid. Another example would be flame provides heat energy to water. It's never the other way around. It's not water that's providing coldness to flame. Ice cubes receives energy from your fingers. That's something that I already said. So yeah, energy always flow to that one direction. Now you will do a bonding practical. I will talk about it in the next video. So that's the end of second video. All right, see you then.